Okay, we're going to try a new format here and see how this works. Okay, so we're doing 1.6, which is other types of equations and applications. So we're going to look at rational equations, work rate problems, equations with radicals, rational exponents, and equations in quadratic form. So to fill in the blanks here, a rational equation is an equation that has a rational expression for one or more terms. To solve a rational equation, multiply each side by the LCD, which is your least common denominator. And you're going to see that here in just a second if you have forgotten. So you're going to multiply each side by the least common denominator of the terms of the equation to eliminate fractions, because it's easier to solve without fractions, and then we'll solve for the resulting equation. Because a rational expression is not defined when its denominator is 0, proposed solutions for which any denominator equals 0 are excluded from your solution set. So be sure to check off proposed solutions in your original equation. So I'm going to zoom out, or I'm going to zoom in, I should say, so we can just look at this equation right here. All right, so what we're going to do is you're going to multiply every piece by the LCD. And basically the LCD is whatever you have in the denominator. I have a 3 and an x minus 1. So I'm going to multiply this first fraction by 3 times x minus 1. I'm going to multiply this second fraction by 3 times x minus 1. And we're going to multiply this last piece by 3 times x minus 1. All right, so now when you go through, when you multiply 3x minus 1 times 3x minus 1 over 3, the 3's cancel out. And you're now left with x minus 1 times 3x minus 1. Now when you multiply the 3x minus 1 times the second fraction, your x minus 1's cancel. Now you've got negative 3 times 2x. And then when you multiply this, you got x times 3 times x minus 1. Now you can go through and do your double distribution and solve for x. So we're going to go through. So we got x times 3x, so that's 3x squared. So x times 3x is 3x squared. X times negative 1 is negative x. Negative 1 times 3x is negative 3x. And negative 1 times negative 1 is 1. Now you got negative 3 times 2, so that's negative 6x, equals 3x times x, 3x squared. And 3x times negative 1 is negative 3x. Now I can add all of these x's together because they're all on the left-hand side. So I have 3x squared. Negative 1 minus 3 is negative 4. Negative 4 minus 6 is negative 10x. Plus 1, because there's no more terms there, equals 3x squared minus 3x. Now I can go through here and I can start moving things around. So I'm going to subtract 3x squared from both sides and it cancels out. Now I've got negative 10x and a negative 3x, so I'm going to add this 10x to this side over here. So now I've got 1 equals 10 minus 3 is 7x. And then I'm going to divide both sides by 7. And I get that x is 1 over 7. So your solution set, if they want you to do it as a set, is 1 over 7. All right, now I'm going to slide over here. Remember, in the video, you can always pause me. All right, now this time we have the same denominator. So I'm just going to multiply everything by x minus 2. So x minus 2, x minus 2. So it cancels. So I've got x equals, this cancels, and I got 2. Now this is going to be plus 2x minus 4. So now I'm going to subtract this 2x from both sides. So 1x minus 2x is negative x equals 2 minus 4 is negative 2. So they both have a negative, so if I multiply or divide either one by negative 1, I get that x is 2. So now the only problem here is that if I were to plug this 2 in, I'm going to have, so if I look at x minus 2 equals 0, x is 2. So that means when x is 2, my denominators will be 0. Since you cannot have a 0 in the denominator, because you can't divide by 0, you can't put nothing into something, so this is undefined. So this would make it undefined, because you cannot have 0 as a denominator, so your solution set would be an empty set. Because nothing's going to work. All right. All right, so now I'm going to scroll to the next page. All right, so here we have solving rational equations that lead to quadratic. So now, all right, so we're going to go through, anytime you have these fractions here, let me see if I can, ooh, I don't want to twist my paper. All right, there we go. Get rid of that. I don't know why there's a pink dot there, but here we go. All right, so we have x minus 2 and x, and we have x squared minus 2x. Well, keep in mind, if I were to multiply this x times x, I'd get x squared, and x times negative 2 would give me this. So this piece right here is actually your least common denominator. So I'm going to go through here, and I'm going to say, all right, I need to multiply by x times x minus 2. Pulled that down too low. So I'm going to multiply this piece by x times x minus 2. And I'm going to multiply this piece by x times x minus 2. All right, it cancels here. So now I've got x times 3x plus 2. This x cancels here, so now I've got plus 1 times x minus 2. And this cancels with this, so it's just equal to negative 2. So x times x minus 2, if you just need to see it, is x squared minus 2x. So that's why it cancels. All right, so we got 3x squared plus 2x plus x minus 2 equals negative 2. So I'm just going to go through, move everything around. So I've got 3x squared, 2x plus x is 3x, and that's minus 2 equals negative 2. Well, if I add this 2 to this side over here, I'm left with 3x squared plus 3x equals 0. I don't have to put this 0 here because it just works out. Now I can factor out, because they both have a 3 and they both have an x, so I'm going to factor out a 3x. 3x times x will give me 3x squared, and 3x times 1 gives me 3x. Now take each piece and set each piece equal to 0. Divide by 3 and subtract 1. So if you need to see that. So now we know that we have our two answers are x equals 0 and x equals negative 1. Now I do need to check them, because remember, you can't have a 0 in the denominator. Well, 0 minus 2, that works. 0 squared is 0, and 2 times 0 is 0. So if I plugged in a 0 here, it's going to give me 0 in the denominator, or if I plug it in here. So this one is not going to work, because it's going to give my denominator a 0. So what we're going to do is our solution set is simply just -1 because the 0 doesn't work. All right, so let's look over here at B. All right, so now we've got x minus 1, x plus 1. When I multiply these two together, it gives me x squared minus 1. And if you need to check, x minus 1 times x plus 1, just so you can verify, x times x is x squared, x times 1 is x, -1 times x is -x, and -1 times 1 is -1. These cancel out, leaving me with x squared minus 1. So I'm going to multiply everything by x minus 1, x plus 1. Multiply this times x minus 1, x plus 1. And I'm going to multiply this by x minus 1, x plus 1. The x minus 1's cancel, so I'm left with -4x times x plus 1. And x plus 1 cancels, so now I've got plus 4 times x minus 1. So notice whatever cancels, you're just left with that piece. Now equals, now all of that cancels with all of that, so it's just equal to -8. So go through and do your distributing. -4x times x is -4x squared. -4x times 1 is -4x plus 4x minus 4 equals -8. So -4x squared. These two like terms are opposites of each other, so they cancel out. And I've got 8 minus 4 equals -8. Now I'm going to add this 8 to this side over here. So I got -4x squared plus 4 equals 0. I'm going to factor out a -4 here. So it gives me x squared minus 1 equals 0. So now, -4 equals 0. You don't have to set that equal because that's not a true statement. So now I've got x squared minus 1 equals 0. So now if you remember this x squared minus 1, how it was equal to that. So x minus 1 times x plus 1 equals 0. So x minus 1 equals 0, and x plus 1 equals 0. Add 1 to both sides. X equals 1. Subtract 1 from both sides. X equals -1. So now, if I plug in a 1 right here, I get 1 minus 1, which gives me a 0. That's not going to work. If I plug in a -1 right here, -1 plus 1 is going to give me a 0. So that's not going to work. So your solution set is empty. There is no answer that will work. So your proposed solution, which would be these two numbers, are invalid. So you don't have a solution for this problem. All right, so let's look at the next two. All right, so now we got a work rate problem. So a work rate problem. So let's see. Okay, if a job can be completed in T units of time, let me enlarge this, I didn't realize it got so small, then the work rate, R, is 1 over T of the job per unit time. So the amount of work completed is the rate of work times the amount of time work. So your amount of time that you worked. So A equals rate times time. So the amount of work completed is how fast you worked times the amount of time you worked. So amount of time, A equals RT. So let's look at this first problem here. One printer can do a job twice as fast as another. Working together, both printers can do a job in 2 hours. How long would it take each printer working alone to do the job? So read the problem, read it as many times as you need to. So find the time it would take each printer working alone to do the job. So let's assign a variable. So we're going to let X represent the number of hours that it would take the faster printer working alone to do the job. So the time for the slower printer to do the job alone is 2x hours. So we're going to say X is the number of hours that it takes the faster printer. Oops. So X equals the number of hours for the faster printer. And it says it can do it twice as fast. So that means the slower printer is 2x. So now, up here, it said if a job can be completed in t units of time, then the rate R is 1 divided by the time. So the faster printer R equals 1 over x, and the slower printer R is 1 over 2x. And this is job per hour. So 1 job per hour. All right, so step 2, we assign the variable. The faster printer is 1 over x. The time is 2 because we have a 2-hour job. So think of it like this. Well, as soon as I figure out that this thing, make it stop jumping, I wish I could lock the screen so it wouldn't move. All right, so I'm going to say the faster printer and the slower printer. So I'm just going to kind of make a little table. So the rate, the time, and part of the job accomplished. All right, sorry, that's kind of mushed on there. All right, so we know that the rate for the faster printer is 1 over x, and the slower printer is 1 over 2x. We know the time is going to be 2 hours. So that means 2 times 1 over x is 2 over x. And this is going to be 2 times 1 over 2x. So the 2's cancel. So this is 1 over x. So remember, this is your A equals RT. So now, when you go down and you write the equation, the sum of the 2 parts of the job accomplished is 1. So the faster printer is 2 over x, plus the slower printer is 1 over x. Altogether, it's equal to 1. Because 2 parts are going to complete 1 job. So now we know that x is our common denominator. So I'm going to multiply everything by x. So that cancels. That's a 2. That cancels with that. That's a 1. And that is x. 2 plus 1 is 3. So that means x is 3. Now what does that mean? Now you have to take the x and plug it back in. So if I were to take the x and plug it back in, we know up here, we said that x is the number of hours the faster printer could do the job. So it's going to take 3 hours, or 3 hours to do the job, and the slower printer would have to be 2 times 3, so it would take him 6 hours. So the faster printer is 3 hours. The slower printer is 2 times 3, so that would be 6 hours. So it would take 3 hours for the faster printer to do the job. It would take 6 hours for the slower printer to do the job. So be sure to give both answers. You don't want to, because they wanted to know how long would it take each printer working alone. So 3 hours for the faster, double the time for the slower. To check the reasonable, since the time working together is 2 hours, is less than the time it would take the faster computer working alone, or the faster printer working alone, which would make sense. If it only takes 2 hours for them to do it together, but it takes 3 hours for the faster printer to do it by itself, and 6 hours for the slower printer to do it by itself. So check the reasonableness of your answer. All right, so now let's move on to the next one here. So equations with radicals. So now if P and Q, well, all right. If P and Q are algebraic expressions, then every solution of the equation P equals Q is also a solution of P to the nth equals Q to the nth for any positive integer n. So if you have two things equal to each other, if you raise them to the exact same power, they will still be equal to each other, because that whole what you do to one side, you do to the other side still applies. Be careful when using it, though. It does not say that the equations P equals Q and P to the n and Q to the n are equivalent. It says only that each solution of the original equation P equals Q. So, oh, mercy. Okay, guys, I want to apologize. I'm not sure what's going on here. That each solution, okay, for some reason it thinks I'm writing in crayon. I don't want crayon, I just want a regular old pen. Okay, there we go. That each solution of the original equation P equals Q is also a solution of the new equation. So what we're going to do is we're going to isolate the radical on one side of the equation, raise each side of the equation to the power that is the same as the index. So when you have a radical, there's a little number right here. That number is your index. So if I had 5x, this little number is a 2 because it's a square root, and when it's a square root, it's just assumed that it's a 2, like this one here. There's not a 2, so it's assumed that there is a 2. If they wanted, if they said the cube root of 4x, then this would have to be noted as a 3, or the 5th root, or whatever they would tell you. The only one they're not going to tell you is when there's a 2. So, solving an equation containing a radical, or a square root. So they're going to start with square roots. So the first thing we're going to do is we're going to isolate the radical on one side. So I want to add this to both sides. So I'm going to add the radical to both sides. So I get x equals the square root of 15 minus 2x. Since that is assumed to be a 2, then you're going to square both sides. Because if you have a square root of x and then you square it, all of this just cancels each other out and you're left with x. So when you square a square root, whatever's under the radical, and this is the symbol for a radical, Whatever's underneath is what's left. So x squared equals, so when I square this, this is remainder. So 15 minus 2x. So now I can solve this. I'm going to take and move everything over here. So x squared, the opposite of negative 2x is positive 2x. The opposite of 15 is negative 15. So we just moved everything over. Now I have a quadratic. And since I have a quadratic, I can factor this out. So I'm going to use that little Xbox method that we talked about before. Since there's a 1 here, I'm going to put 1s here. 2 in the middle goes down here. And negative 15. 1 times negative 15 is negative 15. Now, two numbers that multiply together to give you 15. 1 and 15, 3 and 5. Now, it has to be a negative 15, so one of the numbers has to be negative, and since this is positive, that means the smaller. So I've got negative 3 times positive 5 gives me negative 15, and negative 3 times positive 5, when I add them, gives me 2. So now take these numbers right here and read them up. So you get x minus 3, so this becomes x minus 3, and this is x plus 5, sorry, equals 0. So now take each piece. X minus 3 equals 0, so x is 3, and x plus 5 equals 0, so x is negative 5. Now, plug it back in, because you have to double check your proposed solutions. So if I plug in a negative 5 here, let's see. Oops. All right, so we go up here, we plug in a negative 5. So if I plug in a negative 5, I've got 15. Well, so check your proposed solutions here. So x is negative 5 and x is 3. If I plug in a 3, 15 minus 2 times 3 is 15 minus 6, which is 9, which equals 3. And then if you plug in the negative 5, so we got 15 minus 2, negative 5. We got 15 plus 10, so that's 25, and that gives me a positive 5. So the only solution that works here is your 3. This solution set does not work, so x equals 3. All right, let's look at the next example. All right, so here we have 2 radicals. It says to isolate. So since they're on both sides, what we're going to do is we're going to move one of them over. So I'm going to add this one over here. So I've got 2x plus 3 equals 1 plus the square root of x plus 1. Because we're going to take this because it's a minus, so we're going to move it to the other side and make it plus. All right, now, these can get a little bit messy. I wish they'd given me a little bit more room. All right, so we're going to do the same thing. We're going to go ahead and square both sides. So when we square this side, everything cancels out, and we get 2x plus 3. But over here, we're going to have 1 plus the square root of x plus 1 times 1 plus the square root of x plus 1. So we're going to do that double distribution thing. So I'm going to keep writing this over here down because we can't change it. 1 times 1 is 1. 1 times the square root is the square root. The square root times 1 is the square root. And the square root times the square root is just x plus 1. So think about the square root times the square root. That's like saying squared. So when you square a square root, it's just x plus 1. All right, so here we've got 2x plus 3. I've got x plus 1 plus 1, so x plus 2. And then there's 2 of these, so plus 2x plus 1. So I'm just going to call it square root instead of saying what's underneath every time. All right, so I'm going to move this x over here. I'm going to move this 2 over here also. So 2x minus x is x. 3 minus 2 is 1. Cancel, cancel. Now I've got 2x plus 1. So now I need to square it again. So now I've got x plus 1 squared. Oops, let me erase that piece, sorry. Times x plus 1 equals 2 squared is 4. And when I square this, it just becomes x plus 1. So you have to do it 2 times when there's 2 square roots because you got to get rid of both of the square roots. All right, so now we got x times x, x squared. X times 1 is x. 1 times x is x. And 1 times 1 is 1. Now distribute that 4. So now I got x squared. These are like terms. 4x plus 4. All right, so I'm going to scroll up a little bit. All right, I'm going to move this 4x over here, and I'm going to move this 4 over here. X squared minus 2x minus 3 equals 0. Now I can factor this piece out. These probably take longer than any problem that you're going to do this section. And that's because you have to square those square roots 2 times, then factor them. All right, so I'm gonna go I'm gonna do this. I'm gonna take this piece right here, and I'm gonna bring it up here so I have some room. X squared minus 2x minus 3 equals 0. I'm gonna factor that out. We have a leading 1, a negative 2, and a negative 3. I know negative 3 times 1 gives me negative 3, and negative 3 plus 1 gives me negative 2. So I've got x minus 3 and x plus 1, and that equals 0. So take each piece. X minus 3 equals 0, so x is 3. X plus 1 equals 0, so x is negative 1. So here are my 2 proposed solutions. And when I plug them both in, they're both going to work. So when I plug them into the original equation up here, so if I plug in a 3, this is going to be 6 plus 3, which is 9. So 2 times 3 plus 3 is the square root minus the square root of 3 plus 1 equals 1. So does it work? So you've got the square root of 9 minus the square root of 4. The square root of 9 is 3. The square root of 4 is 2. And that checks out. And then you do the same thing with negative 1. You plug it back in, see, does it work? Because if it doesn't work, then you can't use it. So your solution set here is negative 1 and 3. Both of them will work. All right, so that was a lot. So let's try one that is maybe not a square root. All right, so we've got cube roots. So the first thing I want to do is move this one over because you only want 1 on each side. So I've got the cube root 4x squared minus 4x plus 1. And this is a minus, so when I move it over here, it's going to become positive. So the cube root of x. So the opposite of a cube root is to cube it. So So we're just going to raise each thing to the same number as this, because it's going to cancel out. So we get 4x squared minus 4x plus 1 equals, that cancels with that, so we get x. So let's subtract this x. So now I've got 4x squared minus 5x plus 1 equals 0. All right, so let's factor this out. So since we have 4's here, is this 4 right here? So 4 times 1 is 4, and then we got a negative 5 here. So I know negative 4 times negative 1 will be 4 when I multiply, and negative 4 plus negative 1 is negative 5 when I add. This one will reduce to negative 1 over 1, because 4 will go into it, both of them one time. So now these are going to be my factors. So I've got x minus 1, and this one on this side is 4x minus 1. X minus 1 equals 0, x is 1, and 4x minus 1 equals 0, 4x equals 1, x equals 1 over 4. So there's your two proposed solutions. If you plug them back in, then you can see if they work. So if I were to plug this in, so 1 squared is 1. So let's see, all right, so if we're gonna check, so 4 times 1 squared minus 4 times 1, and you could actually type this into a calculator just to get your numbers. So this is the cube root. 1 squared is 1, 4 times 1 is 4, minus 4 plus 1. Those 4's cancel out, so you've got the cube root of 1 minus, and you're just going to replace that with a 1, so the cube root of 1. Well, the cube root of 1 minus if you have a cube root of 1 and you lose it, the answer is 0, and so that checks. So we know that this is a good number. Same thing's going to happen when you plug in a quarter. So our solution set is a fourth and 1. Let me double check I didn't miss negatives. Okay, so there's your solution set. So 1/4 and 1. All right, make sure there's nothing else on this page. Okay, now an equation with a rational exponent. I am missing something here. An equation with a rational exponent contains a blank or blank raised. Okay, I'm missing my slide that has my okay, we'll come back to the blanks. So here, if we look at this one, this is x to the 3/5. So what you're going to do is, let me enlarge this and let's focus on this. So you're going to raise this to the reciprocal. So 5/3 would be the reciprocal, but you got to do the same thing to this side. And I know it looks super weird, because what's going to happen is this is going to be, what happens is the 3's cancel and then the 5's cancel, so you get x equals. So now what this means, 27 to the 5/3. That means 27 to the 5th power from there. This number means to take the cube root. So if I take, not 25, that should be a 27. So 27 to the 5th power, and then you're going to take the cube root of that. So when you go through, and you're going to do it in the calculator, So the cube root of 27 to the 5th power is 243. So then you go back up here, and now your answer is 243. So it didn't look as bad. So your solution set is 243, or x equals 243. All right, let's look at this next one. So we're going to do the same thing here. All right, so we're going to raise this. So we're going to say, okay, let's raise this to the 3 over 2. So we're going to raise this to the 3 over 2. So all of this cancels out, and we're left with x minus 4. This means 16 cubed, and we're going to take the square root, because remember, 16. So you're going to say plus or minus square root of 16. So it's the square root of 16 cubed. So when you do square roots, it's always plus or minus. And this comes out to be plus or, because the square root of 16 is 4, and 4 cubed. So plus or minus 4 cubed. So plus or minus 64. So x minus 4 equals plus or minus 64. So think of it as x minus 4 equals 64, and x minus 4 equals negative 64. So you have two proposed solutions. So you're going to add the 4 to both sides. So x equals 68. You're going to add 4 over here as well, because it's still minus 4. X equals, now negative 64 plus 4 is negative 60. And then if you plug these back into your original equation, they both work. So your solution set is negative 60 and 68. All right, now equations in quadratic form. So we have AU squared plus BU plus C, where A is not 0 and U is some algebraic expression. So we're going to use a little bit of substitution. So instead of AX squared, we're going to say that U is equal to some expression. So for example, if those were U's, the math is easier, because then you can come back in and replace it after you've actually solved. So we're going to say, let U equal x plus 1. So I'm going to replace this with a U. So this is U to the 2/3 minus U to the 1/3 minus 2. Actually, let's do this. I have a better, to clean it up a little bit. Let's erase that part. So we're going to say, let U equal x minus 1 to the 1/3. Let's just get rid of the fractions and the craziness all at once. So if this piece is 2/3, then we have at least 1/3 in there. So this is U squared. And this whole thing is U. Minus 2 equals 0. So now I can factor this out the same way I've been factoring it out with just an x. So we have a 1 leading in. 1 times negative 2 is negative 2, and there's a negative 1 here. So I know that negative 2 times positive 1 is negative 2, but negative 2 plus 1 is negative 1. So now this is U minus 2, and this is U plus 1. So now I'm going to find what U is so I can plug this back in. So U minus 2 equals 0. so u is 2. U plus 1 is 0, so u is negative 1. So now I'm going to go back up here and plug this in, because this is the step everybody always forgets. So now I'm going to plug these back in. So I've got a 2 and a negative 1. So I'm going to have to do this twice because it says that u is equal to this, but I have 2 u's. So we're going to do the first one. So negative 1 equals x plus 1 to the 1/3. So I'm going to raise this one to the 3 over 1, so that cancels out. So this is x plus 1. But I got to do the same thing over here. I want to raise it to the 3. 3 over 1, same thing. So this means negative 1 times negative 1 times negative 1, which is negative 1. All right? So I'm going to erase that little part right there so it doesn't look so messy. So that is a negative 1. So now if I subtract this 1 from both sides, I get x equals negative 2. So there's one of my values. So now I'm going to do the same thing. Now I've plugged in this one, so it checked. Now I got to do this one. So let u equal 2. Now this is x plus 1 to the 1/3. So we're going to raise this to the 3rd power. So we got to raise this to the 3rd power. So all of this cancels out. So we get x plus 1. Now 2 times 2 times 2. 2 times 2 times 2 is 8. Now subtract 1 from both sides. So your solution set is negative 2 and 7. So you almost have to do 2 problems in one, because you find your u's so that you can substitute them back in, and then you find the actual value of x. So it's a lot. It is a lot. All right, let's do one more here. All right, so now we've got, we got x to the negative 2. So we're going to let u, so u is going to equal x to the negative 1. So we're going to let it equal this piece right here. Because if I multiply this by 2, this is going to be 6u squared plus u equals 2. So this whole thing became a u, and this thing is a u squared. So now we got 6u squared plus u minus 2 equals 0. So let's factor this out. So we have that 6 leading in. 6 times negative 2 is negative 12. There's a 1 right here, so let's bring it down. So I know that 4 times 3 is going to give me 12, and they're also close to being 1. So 4 times 3, so it needs to be a negative 3. 4 minus 3 is 1. 4 times negative 3 is negative 12. Check to see. 2 will go into this 2 times. 2 will go into this 3 times. So this one is going to be 3u plus 2. Because remember, we're using u's right now. 3 will go into this 1 times. 3 will go into this 2 times. So this is 2u minus 1. So now I've got 3u plus 2 equals 0. 3u equals negative 2. U equals negative 2/3. And I've got 2u minus 1 equals 0. 2u equals 1. U equals 1 over 2. So now we know what u is. So now we have to plug u in and find out what is x. So negative 2/3 equals x to the negative 1. All right, so if we have x to the negative 1, that is the same thing as 1 over x. So let's do this. Let's go negative 2 over 3 is the same thing as 1 over x. So basically what you're going to do here, the easiest way to explain it, I think, would be to just cross multiply here. So you got negative 2x equals 3, and then divide by negative 2. X equals negative 3 over 2. So this times this. That's kind of the easiest way to explain when you have a negative exponent. And so now we're going to do the same thing with the 1/2. So now we have 1/2 equals x to the negative 1. So 1/2 equals 1 over x. Cross multiply is x. Cross multiply is 2. So that one is x equals 2. So your solution set is negative 3 over 2 and 2. All right. So when you're using a substitution variable and solving an equation that is quadratic form, do not forget the step that gives the solution in terms of the original variable. Our original variable here was x. So all it's saying is make sure that when you find your u's, that you plug them back in to this where you said let it be something, so that you can actually find the answers that they want. All right, so we got this last one here. We have x to the 4th and x squared. So we have an x squared, so we're going to say let u be x squared. So now I've got 12. Well, if x, well, what's going on here? X squared. So if I have x to the 4th, and this is x squared, then that means u squared, because if I square this right here, it's going to give me x to the 4th, minus 11u plus 2 equals 0. So that's going to be so if we factor this out, so we have a 12 leading. 12 times 2 is 24. We have negative 11 here. So what two numbers multiply together to give us negative, add together to give us negative 11? So think about, we got 1 times 24, 2 times 12, 3 times 8. Well, I'm seeing 3 and 8 as being 11. So if I made this negative 3 and negative 8, two negatives make a positive. So negative 3 and negative 8 give me negative 24, while negative 3 plus negative 8 gives me negative 11. So now I'm going to take and simplify. 3 will go into this once, 3 will go into this 4 times. So this is 4u minus 1. 4 will go into this 2 times, 4 will go into this 3 times. So this is 3u minus 2. So 4u minus 1 equals 0. 4u equals 1, u equals 1/4. 3u minus 2 equals 0. 3u equals 2, u equals 2/3. So I have my two u's that I have to come back up here and plug in. So I'm going to erase this thought here so I can use my space. So if u is 1/4 equals x squared, so if I have an x squared, I have to take the square root. So I have to take the square root of this. So that's going to be plus or minus. The square root of 1 is 1. The square root of 4 is 2. So I've got plus or minus 1/2. Now I'm going to do the same thing here with the 2/3. So now 2/3 is equal to x squared. take the square root of both sides. So plus or minus the square root of 2/3 equals x. So this one would simplify. I mean, you could say x is plus or minus the square root of 1/4, but since 1 and 4 are perfect, this is kind of where you want to simplify to. 2 and 3 are both prime numbers, so you can't take the square root of either one. So you would leave your answer like that. If they ask you to simplify it one step further, because I know we discussed radicals in the denominator, you would have to take this a step farther. So you would have to do the square root of 2 over the square root of 3. And you would multiply top and bottom, so that would be the square root of 6 over 3. So x would be plus or minus the square root of 6 over 3, depending on how far they want you to simplify it. I'm thinking that my math lab will accept this as your answer. If it doesn't, then you would have to do this extra step right here. So if you get to this point and you put this answer in, because it is the easier answer, if it tells you to simplify it one more time, then this is what you have to do. You have to rationalize the denominator to get it simplified to where there's no square roots in your denominator. All right, and I think that is the last piece. So please reach out if you have any questions, and I will talk to you soon.